So let's start. So my name is Ido Erev. I'm from the Technion in Haifa, Israel, and I'm a psychologist. But as you will see, I drank too much coffee with Al Roth, and I'm in some respect, so my psychologist friend don't believe that I'm a psychologist and I'm not an economist. I'm really interested. I like the rationality assumption, but in a different way than the way Aumann presented it. So I'm pretty safe he's not going to come, I hope, because I'm going to present a different view. So I'm buzzard since, as I said, because of this coffee with Al, and then I'm going to present a paper with my good-looking ex-students, and but I will probably focus on two of these papers. So I changed a little bit the title, actually, in response to Aumann's talk. And let me tell you what really interests me in my career. This is now for many years now. What really interests me is the fact that many laws and regulations that were designed under the rationality assumption are highly effective. So there is really something there in the rationality assumption that is not just hand-waving. It's something really serious. And one thing that you saw in your, those of you who went to the tour to see the old city yesterday, much of what you saw was affected by an insight by this guy, Hillel the Elder, who presented one of the most elegant example of effective use of rational decision theory. Hillel noticed, this was 2,000 years ago, he was a spiritual leader of the Jewish people at that time. He started, I think, before, his role was before King Hord was a king of Judah, I guess it was called then. And he noticed there was a problem with one of the law in the Bible. The law was that, and a really social and nice, apparently nice law, that if you give a loan to someone, if you borrow money from someone, every 7 years the loan is cancelled. So if you cannot pay, don't worry. Every 7 years this will be cancelled. Everything will be good. If you're a poor man, we, as a Jewish people, we care about you, so the loan is cancelled, everything will be good. But Hillel was a smart man, and he did the backwards induction. He said, well, there's a problem here. You know, if this is a rule, then some rich man, a smart rich man, will realize that if he lend money to someone, maybe he will not return the money to him. So if he does a backwards induction, people will not give money. And that will create a problem. So he canceled this rule. This was a post-ball correction. He basically did the backwards induction, and he says we have to cancel this rule, not in order to help the rich people, but in order to help the poor people. Because if this law is in power, rich people will not lend money to poor people. And this insight had a big effect because after this correction, the prosperity of the buildings that you could see around here, including the Western Wall, was built after this correction. So during the days of King Hord, which were after Hillel Insight, a lot of good things happened around here. And this is only one example. I think there's many examples that very basic laws and regulations that are based on the assumption that people are more or less rational are really effective, and many of the things that makes our world a better place are based on the rationality assumption. Nevertheless, research in behavioral economics reveal clear violation of this rationality assumption. So, for one hand, the rationality assumption appeared to be really, really useful, but it's clearly wrong. And the question is, how can we, so my research, I tried to clarify this apparent gap between the usefulness and the clear violation of the rationality assumption. Under the popular explanation of this gap, and Professor Aumann presented this as one of his stories, or one of his main arguments, the gap reflects the fact that the experimental studies that reveal deviation from rationality focus on contrived one-shot decisions that people do not understand, But in natural setting, when people have an opportunity to learn, they will eventually learn to select the rational choice. So this is one explanation. In the current talk, I will explore this explanation, but also provide a refinement, because this explanation is not exactly correct. It's not exactly consistent with my data, and I will propose an alternate, refined explanation. In order to do that, in the first paper, what we're going to do, I'm going to try to replicate in the lab 6 of the most robust deviation from rational, from expected utility theory. The St. Peter's, well, not expected utility. For me, rationality is really the expected value rule. In fact, in a paper with Al, we wrote that Bernoulli was the first behavioral economist. He already introduced one too many behavioral parameters. So for me, rationality is the expected value rule. And I'm going to talk about, so I'm thinking about maximization of expected value. So I will ask in my research, can we observe the 6 well-known deviation from rational choice, that is from expected value maximization, in the lab, and what happened after people gain experience. So we will let people play the same game, the same choice task repeatedly, and we ask, would they learn to maximize? I should start by saying that when I started this research in the 90s, after drinking coffee with Al, we were pretty sure that people will learn to maximize, and the results were not exactly consistent with our assertion, and I will present the results. And here is our basic experimental study. This is from the 2017 paper. In the basic experimental task, each participant faced several tasks similar to the experiment that Tom presented. Tom presented a follow-up of that research. And basically, in this task, each participant faced each task in our experiment for 25 trials. In each trial, the participant see a description of the choice task. In this case, it's a full description. We tell them if you select A, you will get 3 with certainty. If you select B, you will get 4 with probability upon 8, 0 otherwise. The participant in the first experiment we ran were students in Israel, in the Technion and in the Hebrew University. And the payoff were in shekels. But we paid only for one randomly choice. And they didn't know how much they get for show-up fee. If they lost, it was taken from the show-up fee that was unknown to them. And the participant could select. Say I select, first trial I select B. Now there were 25 trials. In the first 5 trials, we did not give them feedback concerning the payoff. We just remind them what is selected. So there were 5 trials, I said, to select, and they get just the only reaction that they saw on the computer screen was what they selected. By the way, stop me if the method is unclear. It should be, everything here should be clear. And then starting at trial 6, when they selected, we actually gave them feedback concerning realization of the payoff. So if they selected B, the payoff was, so B appeared on the key they selected, and they also saw the foregone payoff on the keys that they did not selected. And to be on the safe side, we also told them, you selected B, your payoff is 4. Had you selected A, your payoff would be 3. Okay, notice that in this experimental design, the feedback does not add useful information, because everything is described to the subject. But under the assumption that the deviation from maximization reflects some failure to understand, maybe once people start getting feedback, they will eventually learn to do the right thing. This is more or less what we thought. But let me now present the results. Our early results supported our hypothesis, and maybe some people here even were in a talk in which I presented this argument that experience actually lead people toward maximization. Maya might remember, I actually went to one conference and I presented that, and Amos Tversky was not impressed. He said, well, Ido, what do you want? If you hit people with a 5-kilo hammer, they will learn. But that assertion was too optimistic. But let me show you what we did get. So notice that this first problem that I'm going to present here is really very similar to one of the famous problems that Kahneman and Tversky study in their 79 econometrica paper, prospect theory. But in their experiment, the payoff were hypothetical and they were in thousands. And we studied in shekels, and it was real. So, and the question, can we replicate the results? They basically found a reflection effect. That is, in the light problem, subjects prefer the 3 with certainty. And so they behave as if they are risk averse in the gain domain. And in the loss domain, most participants selected the lottery. That is -4 with probability 0.8. That is, in both problems, people deviate from maximization. And the top deviation that appear to select risk aversion. And at the bottom, in the dark problem, as if people exhibit risk seeking in the loss domain. So we first see what happened in the first 5 trials. So in the first 5 trials, we got a replication of the Kahneman-Tversky pattern. That is, we find what you see here is a proportion of people selecting B. And we can see that in the light problem, we get more risk aversion. So most participants don't select, most people don't select B, although B have higher expected value. But the difference when you study it for shekel rather than for real money with shekel is smaller than what Kahneman-Tversky got. Kahneman-Tversky got here 20% and here 80%. But at least we get it in the same direction. Now what happened when people gain experience once we start giving feedback? This is what happening. So in this task happened exactly what we hypothesized, that there is a learning toward maximization. So people learn to maximize expected value in the gain domain, that is selecting the 4 with probability 0.8 over 3. So after 25 trials, it's to get to 65%. And learn to avoid the -4 with probability 0.8. Pretty boring results, but this was the results. What can we do? But this appeared to suggest that, yes, people learn to maximize. The next problem we studied was Kahneman-Tversky replication of a Hillel paradox.
So can you get that some proportion of the people there? No? What was the proportion of the people?
Well, this is 65% of the people learn to maximize in both conditions.
So you still have a big chunk there.
Yes. No, it's going to be, the results going to be more interesting. I'm not going to bore you to death. There will be some surprising results. That surprised me, at least. Maybe you guys knew it all
But
along.
then you say that maximum, yeah, but it's not clear that that's the right thing to do, right? If you're risk averse, then...
Yeah, well, according to Rabin, this is, you shouldn't be risk averse when we're talking about checkouts. But this is not the main issue. We'll get to something more interesting. More interesting than that for sure. If it will be really interesting, I'm not so sure. It is interesting to me. So let's talk about the Hillel paradox. So Kahneman-Tversky replication of the Hillel paradox. This problem that you already know, that here people prefer the 3 over the 4 with probability 0.8 in Kahneman-Tversky results, and also in our replication from description before they get feedback. But then when you divide the probability by 4, and now this should not affect preference according to expected utility theory, then most people now actually prefer B. So this is a Hillel paradox. And we try to see if we get it for real pair of small amount, and yes, we get it. So the deviation that we get here is exactly like the Kahneman-Tversky, we get the Hillel paradox. And Kahneman-Tversky called it a certainty effect. It's related a little bit to one of the points that Alman made in his talk, his certainty thing. And what happened when people gain experience? In this case, we did not get learning to maximization in the dark problem, but the Hillel paradox was eliminated. So after 20 trials with feedback, we don't get the Hillel paradox. We even get something that were like going into reverse Hillel. In fact, in another experiment, we're running for 100 trials, and we do get a reverse Hillel paradox.
How many trials in each block?
5 trials in each block. So there are altogether 25 trials in this experiment. Okay, so in this case, Hillel paradox, we get it before people get feedback. Once they get feedback, immediately it disappears, and maybe even going to be reversed. So that was a little bit more interesting, but still not very interesting. So
what if you repeat and don't get feedback? Do you have results on that?
yeah, actually, reviewer asked us to do it. So this is, luckily to us, we had the first 5 trials repetition without feedback, and we actually get strengthening of the Hillel paradox in this first 5 tries. So we actually have, and it's in the paper. Okay, so feedback eliminates this paradox. Now let's talk about the Elseberg paradox. So the Elseberg paradox is, this is a simpler version of the Elseberg paradox, just passed away last week. He was a good man and even contributed to the, when he was in academia. And basically the idea there is that subject was supposed to, in this problem here, you know for sure that it's 10 with probability 0.50 otherwise. Here you know it's 10 with some probability, you don't know what's the probability, 0 otherwise. But when we start giving feedback to the subject, the probability was also 0.5. Subject did not know that. And initially we got the Elseberg paradox, that is subject, the proportion of people prefers the ambiguous problem was only 30%. So we get a little bit of the Elseberg paradox. What happened when we get feedback? It is eliminated by feedback. So all these famous phenomena, we can replicate them with small amount real perf, but feedback, for some reason, eliminates them. A little bit boring, but you know, we expected, yes. But we got, but yeah, I'm still promising more interesting results.
I'm not sure I would say that you eliminate it. They simply learn the probability. They learn the probability.
Yes, yes. Well, you know, we presented in Gilboa's conference with people like ambiguity aversion.
It's no longer ambiguous.
Okay, so let's get to more interesting results. So you could say that, but there's still more ambiguity. You know, here I tell you it's 0.5, here I don't tell you. So it's more ambiguous, but maybe less ambiguous after you get feedback. Okay, let's get to some more interesting results.
I mean, another thing you could have done would be to change the probability.
Yes.
But in a way that preserves 0.5 as the...
Yeah, we actually, there is a paper by Ori Plonsky, my co-author, and Yoram Alevi is doing that, and we get the same results. And this is Yoram Alevi, he's a careful guy, not a psychologist like me. Okay, so he's the most careful economist that I know. Okay, so let's look at this problem here. This time we are going to talk about a phenomenon that actually was observed in real life, that many people buy both insurance and lotteries. And this Savage and Friedman wrote about it and provide an explanation. Kahneman and Tversky provide a very elegant explanation. They replicate it in the lab with different numbers, notice numbers, and basically observe that even in the lab, even people behave as if they like lotteries like that. So long shot lottery, people behave as if they like 101 probability, 1 in 100, one otherwise expected value of 2 is preferred over 2, and in the loss domain we get a reversal. People behave as if they buy this lottery and as they buy this insurance. This is a common result. So the question, do we get it in our experimental setting? And initially we get something of that sort, so we get it in the direction. More people buy the lottery than buying more people buy the lottery and most people buy the insurance. But it's not a big difference. What happens when when people gain experience? We get this result. So now it is a little bit more interesting. It's not learning toward maximization or to indifference in this case or to risk aversion. We get people behaving as if in Kahneman, Tversky, in prospect theory, and the explanation of buying insurance and lottery is that people are oversensitive, are overweight rare event. Our results suggest that after people gain experience, they start behaving as if they believe that it won't happen to me. So proportion of people that buy the lottery goes down from 55 to 40, and proportion of people that buy insurance or choose not to buy insurance go up from 48 to 65%. So most people don't want this insurance and don't want this lottery. Okay, this finding, we find it in many other experiments in many settings, is now in the psychological literature is called, we called it in a paper with Ralph Fertwig, we call it a description experience gap. And this is a finding when people make decision from description. They behave as if they are too sensitive to rare event, But once they start getting experience, they start behaving as if they believe that it won't happen to me. Yes?
Does the result differ conditional on the realization of the previous chaos?
We will talk to that. This will be another interesting thing that is happening that we could not predict. In fact, it took me 10 years to discover what sequential dependencies in the data. Okay, so this is called the description experience gap. Now, another result that we get that also was surprising, well, I guess it was not so surprising at that point. Look at this trivial problem. In both cases, you have the probability of E is 0.5. We tell that to the subject. In both cases, you have a dominant strategy. Either A give you 6 or 0 with equal probability, and B in this case give you 8 or 0. So it's no brainer. Of course, people would like the 8 over 6. And here, again, it's 6 or 0 or 9 or 0 with equal probability. The trick is that here there is positive correlation. So if you get you get 6, you also get 8. Here's a negative correlation. If you get 6, you're going to get 0 here. And if you get 9, you get 0 there. So what happened here with experience? And now we get some results that surprise even economists. So in this case, we get learning in the wrong direction. So they start with high maximization rate. In the dark problem, when there is positive correlation, people learn to maximize. In the lighter problem, maximization rates fall from 95% to 84%. So in this case, people learning take people away from maximization. Okay? We also tested, so feedback in this case appeared to increase what is sometimes called the regret effect. What happened with loss aversion?
What's the explanation?
Well, I will explain. There's many explanations, but the game I'm playing is I don't, one thing I don't like about behavioral economics, we have each phenomenon we have a different explanation. I want to have one explanation for all the phenomena I'm going to present in these 3 hours. So we'll have to wait for a minute and I will present my explanation. So here is a problem that, well, this one we didn't plan in advance. This was serendipity results. We have one problem that will give you 13 with certainty, and another problem that can give you a gain of 50 or a loss of 45, expected value of plus 12. And initially, subject, in this case, A is predicted both on expected value maximization, but also under loss aversion. And initially, we get that, in fact, the proportion of people selecting B is only 30% or so. But when people gain experience, they actually learn again in the wrong direction, and they become indifferent between these two prospects. That is, as if this B that has lower expected value and can also lead to large loss is actually as attractive as A. So loss aversion also doesn't really hold when people start gaining experience. The one phenomena that we found that is not affected by feedback, and this could be a clue, this is our effort to replicate the St. Petersburg paradox, but we only allow them up to 9 flip of the coin. So basically, you can choose between 9 for sure, or this lottery with expected value of 9, which simulates the St. Petersburg paradox. And in these settings, we get experience does not affect behavior. We get risk aversion all over the way. So it did not change. Okay, so this is our effort to replicate this result. So the 6 famous phenomena, some of them are eliminated by experience, and some of them are reversed by experience, and one is not changed. So let me try to summarize the results. So here is my summary, and yes, go ahead, yes.
Sorry, might be a bit too late, but you have those blocks. What's the meaning of blocks? Is there something happening after each block?
After the first block is without feedback. Thanks for clarifying it. The first block is without feedback, and the other blocks, just for symmetry, we present them in for. But there are just 20 trials with feedback. Yes.
So in St. Petersburg's paradox, what were your expected results? Because I thought the paradox is that the expected value is infinite, but you have truncated.
Yeah, you know, one thing that really fascinates me about economists, that you take the St. Petersburg paradox as education for for risk aversion. Come on, the casino doesn't have infinitely amount of money, right? You should not, even if you maximize expected value, you should not pay more than 20, because after the casino lose $1 million, they're gonna bankrupt. So in our case, the casino has only 256 shekels, which is also a lot for our research budget. So, okay, so yeah, think about risk aversion. Why you guys believe in risk aversion? You tell the student about the St. Petersburg paradox. This is really silly example.
That's why Bernoulli believed in this.
Well, Bernoulli also has the example of the rich man and poor man in and taking. Okay. But I said, you know, and Al protect me on that. We think Bernoulli was too behavioral to my taste. Okay, so here is our explanation. The beginning of the explanation. It's going to be several stages. But notice something interesting here, that in all the example I presented here, experience had the same effect. In all the cases, it didn't always lead toward maximization, but it always moved behavior from the decision in the description and to the probability that B prevents regret. Okay, so what I write here is a probability that B prevents regrets. So in the first problem, for example, 2 for sure, or 101 with probability 1 in 100, probability that B prevents regret is only 1 in 100, because only if you win 101, you are happy. Otherwise, say, oh, that was stupid to take this bet. So here, B prevents regret only 1%, and what we found is learning down from 55 toward 0.4. Here again, probability that B prevents regret is only 1 in 20, because if you win the 20 with probability 5%, and we get a decrease. Here, B, if you select B, actually B prevents regret with high probability, because most of the time B gives you 0, and now we get an increase. So we get from 0.48 up. And this happens in all the problem we find. And we didn't only run this task. We ran, as Tom said yesterday, we ran 150 problems, and this was general. Always experience move people toward the option that minimizes the probability of regret. So this was a general phenomenon. So this is still not a model. I will present a model too, but also with some handwaving. I will not do equation here. So here are some implications just from the pure experimental results before getting into modeling and deep thinking. First, feedback affects choice behavior even when it does not add information concerning the incentive structure. And here I also have a critique of mainstream economics. Economists like to believe that when you present a description to the subject, they believe it. And the only problem is that maybe they will not understand it. But I think that when I get information from my, from my financial advisor, or from my bank, or from my cellular provider, I don't always believe everything that they tell me. So maybe the reason we get this effect is because the subject, why did this feedback that does not add information change their behavior? Maybe because they were not sure that the description is accurate. This is one hypothesis. I will return to it later. Now, the most important argument is that feedback, the effect cannot be explained with assumptions that learning just increases maximization, right? So sometime we get learning toward maximization, sometime we get learning in the opposite direction. What we always got is learning towards the direction of the strategy that minimize the probability of regret. And this was a point of a paper I wrote with Al. And here is an application. And I guess my main interest is in application. So I want to understand under which situation. So I agree with Professor Aumann that mainstream economics has many useful ideas. But not all the ideas of mainstream economics are useful. The question, can we know ahead of time which idea is going to be useful? And this is not only in economics, and generally on mechanism design. could be in engineering design. Here is an example, my favorite example, and what I want to do in my research, and I would like to encourage you guys to do the same, is to find more examples like that. And my favorite example is a seatbelt buzzer, not a seatbelt. The seatbelt, we had a discussion here about the 60s. I was also around, but as a kid in the 60s. I remember that my father bought a new car and it had a seatbelt in the 50s, but no one used a seatbelt. There were research arguing that seatbelt can save life, but no one believed it, and actually there was some papers suggesting it doesn't really save life. But no one used a seatbelt. But then the government thought that the seatbelt is good, it can save life and can save the government money. And there was rule that you're supposed to put wear the seatbelt while driving, and there was a fine for people that did not use a seatbelt. And then there was already evidence that not using the seatbelt while driving is really not a rational choice because you're really risking your life. But people still didn't use a seatbelt until some engineer invented the seatbelt buzzer. This was only happened in the 90s. And this had a huge effect on people's behavior. And my explanation for that is exactly this argument, that people learn to do the rational thing if this rational things also minimize the probability of regret. And as you all, as a driver among you know, that if you get to the car and start driving without the seatbelt, you regret it later because of this noising noise. And the idea is how to come up with more mechanism like that, that when you do the wrong thing, you regret it. You know, there's some ideas in economics. Like one example is the difference between first price and second price auction. With first price auction, if you do the right thing, often you regret it. You know, you bid high, you won, and you say, oh, too bad I didn't bid an epsilon above the second price. With second price auction, you don't have this problem, right? If you do the right thing, you don't regret it. So the idea is to come up with more mechanism like that, so basically what I'm suggesting, my hypothesis, this hypothesis in the paper with Al, is that so we have lots of good ideas like the Post Bowl and the second price auction, a lot of good ideas in economic research, but not all the ideas are as useful. And here is a heuristic to know which idea will be useful. So what we suggest for the real economist among you, when you do analysis, try to find a method that not always maximize expected utility, but also minimize the probability of regret. And it is our hypothesis that these methods will be more robust. Okay.
Just to comment, when it comes to auctions, if I'm a seller, your argument says that I should use a first price auction because people will bid more to avoid regretting losing.
Yeah, but that will increase inefficiency. So if you're a government, you shouldn't do it.
If the government cares about efficiency,
Yeah,
that's
yeah.
fine. But
As a seller, that could be. Yeah.
Then they're going to use
Yeah.
the first price
Yeah,
auction.
yeah. But of course, it's more complex there. But with seatbelt, I'm safer. This is why I presented this example. And nowadays, by the way, why this is interesting? Because nowadays, with the big data around, we can do many more things like the seatbelt. So I think there is really an opportunity to do that. And in fact, yeah, so this is what many firms are now doing. Okay, so now let's talk about the explanation. By the way, how much time do I have? Maybe I can put more.
It's at 1 o'clock.
Okay, so I have a lot of time. Feel free to ask questions. And, yes, go ahead.
Okay, so and then I have a question regarding the distinction between experience and information, the point you made in the previous slide. So hypothetically, we can say, oh, the description provided in the experiment perhaps is just not enough. Now let's think about the very coherent and very complete way to describe what you will feel we are making this decision for information. Does this description feel the same to you as experience? And not
Well, so actually, this is more or less what I'm going to propose here. So I hopefully my slides will answer your question and tell me if not. So basically, here is my hand-waving model. And this is, by the way, it's not absolutely new. This was a basic idea of Skinnerian psychology. That was a popular view to psychology until 70 years ago or so. So the basic idea is that the effect of feedback can be captured with the assertion that what people are doing, they select the strategies that have led to the best outcome in similar situation in the past. So when I get description, I know that not all the description I got in my life were accurate. Sometimes I was tricked. You know, if I get an email, send me some money and I'll send you money back, then probably it's not accurate. I'm not going to, someone asks me, send me $50, I will return you $1 million. I typically don't send the money. So I doubt this description. And I also doubt the description that sometimes my cellular provider also give me. So the idea is that when we get description, we try to recall what happened when I got similar description in the past. If someone invites me to conference, I read the email, and sometimes they invite me to conference in some exotic places, and then they say submit a paper, so I ignore this email. Sometimes they invite me to Jerusalem, then I believe them that this is real, and they will organize a hotel for me, and that was very nice. So every time I get the email like that, I don't just read the description and believe it. I read the description, and that reminds me past experience with similar descriptions. And so now the question is, why feedback affect our behavior after we get the initial description? Because the feedback affects behavior because it's add more relevant experiences. So I told you in the beginning, this is 4 with probability 0.80 otherwise. So you were not sure that this is correct. As a subject in my experiment, we're not sure this is correct, but they tried. And when they tried, they start getting more feedback, and that helps them revise it's add more information. So notice that this model, although this is a Skinnerian old psychology, it's also very similar to what machine learning algorithms are doing. So basically, when machine learning algorithms make decisions, the way they make decisions is looking at the training data and do some categorization of what is the situation I'm now in, what is similar, and what machine learning algorithm is doing is gives the outcome that was most successful in similar situation in the past. So basically, we suggest that maybe the underlying processes are not simple rules, but more similar to a complex machine learning algorithm. Now, if this, yes?
So all this assumes that you cannot remember all of past experiences, right? So you tacitly assume that you have to select somehow, right?
Well, the assumption here is that, I have a lot of past experiences, but I will select only the most similar one. Because I have some past experience that people invite me to conference and then they expect me to pay. And there are some that they invite me to conference and they actually treat me nice. And I have the respect of talking in front of many smart people. So I should, when I respond to email invitation to conferences, I should try to see, I don't do the average of all the email I got. I take the one that is most similar.
Yeah, but if you were a Bayesian, you would use all of them.
Yeah, so we propose here something more like a machine learning algorithm, like random forest, that does categorization and then eventually selects the most similar one and play best reply to this most similar one. This is basically our model.
This sounds like case-based.
Yeah, it's similar to case-based, of course. Yeah.
So there is an assumption either I cannot take all of history or somehow the rule by which I...
Well, I would like to argue, and maybe I will talk about it, that this, if under the belief that the environment is some Markov chain, this is actually approximate optimal Bayesian strategy. But I'm not going to focus on that. I'm in front of this audience that know about Bayesian models more than me, but we have it in a paper with an example. So, but here is what I do understand. If this is what you do, and you are using this method of relying on the most similar past experiences, case-based or machine learning or Skinnerian psychology, then there are going to be 2 types of errors that you're going to commit. One is overgeneralization, which is relying on past experiences that only look similar to the current task. So suppose someone invites me to a conference in some exotic places, but this is a really fancy conferences. In fact, there are conferences like that in psychology. That famous psychologists meet in some ski resort and have fun and also talk about research. This is really serious conference that is happening in psychology every year. But first time I got this invitation, I thought this is one of these no good conferences. So sometimes I overgeneralize. So I I rely on past experience that only look similar but are not similar. And I would like to argue that most of the research in behavioral economics, in particular, almost all the research that Professor Aumann presented, are example of this kind of mistakes. They are overgeneralization. People use rules that is effective most of the time, but not effective here. So the rely on past experience, in particular rule was effective, but in the current task, in this experiment that suggests deviation, it's not so rational. But this is one which was heavily studied. But the other one did not receive enough attention, I think. And this other type of mistake is what can be called over-discrimination. And over-discrimination, you are now in my experiment. You already had 20 past trials, and you should have learned which option maximizes expected value, because I gave you 20 trials there. But you don't rely on all the 20 trials. For some reason, you think that you're in trial 24, and you think that not all the trials are similar to the current task. You think that you find some pattern, so you rely only on subset of the truly similar past experiences. So this can also lead to deviation from maximization, and I would like to argue that this deviation is the main driver of our results. Yeah.
So these are basically opposite from each other, right? So overgeneralization, you take
Yes.
too many, and
Yeah. Yes.
you take too few past.
Well, you take too many. Yes. Right. Yeah. You can err in both directions. And typically you err in both directions at the same time. You take some that are not relevant, and you don't take all the ones that are relevant, because you only rely on small samples.
Yeah, well, I mean, what's strange is that the way not to err is to take everything, and if you have enough to,
Well, if you take everything, you might have overgeneralization.
not if your rule by which you make decisions.
Oh, if you have the exactly accurate rule and you know the state of nature, and you only, that's good. But you don't know where you are now.
Right, so which of these constraints should I think is underlying this? Because there are many ways I could
Yeah, so
mention
maybe,
reason for which.
yeah, so let me present more data, and then we will try to find a model that at least captures the results. So as I already said, I think that classical descriptive violations, including all the 6 that I present, or all the 29 that Aumann present, some of them were in both, are example of overgeneralizations. And actually, Kahneman and Tversky wrote about that. With their heuristics, they were very explicit. These heuristics are good rules. They work in many situations. But people also use them when they are not so effective. So I think this was well known. But I don't think that the name overgeneralization is common. In fact, I know that if I write this word, I put it in red because this is a red flag for reviewer in psychology. I hate the word overgeneralization because they say you can explain everything with overgeneralization, which is true, but I'm not going to do that. I'll try not to do that. Now, my argument is once you get feedback, this reduces overgeneralization, because now you say, oh, I thought that they said that, I thought that this task is similar to a task that is not true similar, but now I get feedback. And I say, no, that's wrong. Now we get more truly similar experience in our experiment. But this exposes, now it's, after you reduce a little bit of overgeneralization, now the results are more likely to show the impact of over-discrimination. So, and this is my main and important point. These observations that I were not aware of initially. The shift toward minimizing the probability of regret can be captured by assuming over-discrimination. And the reason is that if you rely, let's take extreme tasks, that you rely only on sample of size 1, then you will behave as if you select the options that minimize probability of regret. So this you don't have to assume that people are trying to minimize regret. It's enough to assume that they rely on small samples, that is exhibit over-discrimination, and that's lead to behavior that that moves them toward the options that minimize the probability of regret. Okay, this is something the psychologists don't like. They say once you mention regret, they're already thinking about all the feelings that you might have about regret. We use probability of regret not for the feeling, but this is a summary of the results. Notice, as I already said, that this again something that psychologists and maybe economists also don't like, but I think we should consider that option. That this intuitive classifier, so basically the model that I present here is that people, when they face a new task, they recall past experience, they classify past experience and remember the past experience that are most similar to the current task and select the option that it will do. Now this implies a very complex cognitive model. We cannot hope to write it down because I have many past experiences. Here is one example that maybe I already told some of you over coffee. A few years ago, I biked in England after not biking for many years. And then I heard a truck behind me. At that moment, I remember that this actually happened, Maya will know, in 2013. And a year earlier, Israeli psychologist who won the Israeli prize was killed by a truck. At that moment, I recall... He was biking, yeah. While biking. So it was similar to my situation. So I said, whoa, this truck is coming. And I didn't bike for many years. This was actually in Cambridge. I thought about myself as a famous guy, but I'm going to be killed by a truck. But then at the same moment, I also recall that when I was 17, and this was a while ago, even then, I once biked in the small town I grew up in Israel with my friend in the city center, and I tried to climb on the sidewalk, and I failed, and everybody laughed. So I said, wow, I'm in a tough situation here. So what I ended up doing was to try to climb on the sidewalk, but in an angle like that I will fall on the mud and not to the truck wheels, which I was successful in doing. So basically, my idea here is not that we are aware of all these things, but these ideas comes to mind. The similar stories come to mind where we are in a situation. Typically, we are not aware of that. Maybe I was not aware of that and I just invented it later. By the way, this is one of the things of good thing of being a behavioral economist. I guess is that every time there's something bad happened to me, I come up with say, oh, that will give me an idea for research. So, okay.
Minimize regret that way.
Okay. So here, this is why we cannot hope for a real simple model, or at least not simple, accurate cognitive model like some cognitive psychologists like. But, and here I take the advantage that I have an economist friend, maybe we come up with simple models that will approximate the underlying processes even if it's not exactly correct. And there are two observations that encourage me to believe that maybe we can come up with a simple model. And here is the first observation. It is natural to assume that, so basically what my argument is that when I make decision in my experiments in trial number 24, I recalled all experiments that happened before the experiment started, and also on new experiments, what happened in the first 23 trials. And I think that it's natural to assume some kind of an additive effect or of the two classes of experience. So basically, when I make decision trial 24, I might recall all the experiences that happened before the current experiment, and also the experience that happened in the current task. Now, one nice thing for me as a modeler is that I can see the experience the subject had in the current task. And another good thing is that the experiences that in the very first trial of the experiment, the subject must use his old experiences because he doesn't have new experience. So we can have a good estimate of the impact of the old experiences because this will be captured by the subject's initial behavior before they gain feedback. And we have 5 decisions like that, so we can guess what are their old experience. But once they start getting new experiences, then we can see it.
What do you mean by additive? Do you mean the process the same way? Or what?
No, actually, well, maybe additive is not the best word. Basically, what our model basically will assume that in each trial, I will present our model later, and it doesn't necessarily reasonable, but it fits the data well. That in each trial, you either use old experience or new experiences. This is what the model later will assume. And the other good thing, as I already said, that the impact of the new experiences can be captured with a real simple assumption that the subject behaves if they rely on small samples. So the bias toward behaviors that appear to refer to minimize regret, I don't have to assume some regretful feelings, but it's something really really easy to estimate, which is just relying on past experience on what already happening. So as I already said, in this experiment, if you rely on small sample, that will move you towards the 1, because on small sample, the probability is that in a small sample, you will recall the outcome that happened 1 in 20 trials is small. So if you rely on sample of 5 of size 1, the probability will be only 5%. If the sample is larger, say some size of 5, this will be like 41%, but it still will be small. Yes?
So just to follow up, I don't think my...
But I'm not sure people hear you, so if you can...
Okay. So just to follow up, I don't think my previous question was answered, because I was asking about what is the qualitative difference between information description and experience. I can try a different way of asking, which is, in your experiment, suppose now you ask participants to passively observe other people playing 20 trials. Is that something different, or is that the same?
Actually, we have an experiment that tests that, and it's happened to be empirically very similar. So observing other people and your own experience are similar. As I explained with a bicycle, luckily it was not my experience to be run by a truck. So in our experiment, it's similar, but it's not. But there is open questions there. We have not. We have one paper that I can send you.
Excuse me?
Yes.
I was also wondering, in many of the settings, there could also be this component of endogenous experience. That is, I want experience because I want to learn about something, versus, let's say, I'm just getting feedback, nevertheless.
Yeah.
You
Okay. So one interesting thing about history of science, not very old history, that when we start doing this research in the 90s, when I did research with Al Roth, there was a period in the early 90s that learning research was really popular in behavioral economics, and then it lost its popularity. There was debate of different groups who live in different models, and one thing that I've learned from that is to try to study simple situation. And the early research with study situations, the feedback was only, you didn't get feedback for what you did not select. So you only obtain feedback, you didn't get the foregone feedback. And then some people, there are different way to interpret the results. It could be exploration, it could be error, it could be overgeneralization, and there was a big mistake, a big mess. So I decided, and actually I got this insight, this idea, in a conference when I had breakfast with Reinhard Selten. And he told me, he was with an umbrella. I have, by the way, another explanation for why he walked with an umbrella. When I met him, he was already old and uses umbrella also to balance. So it was rational behavior. And Selten told me, Ido, do you believe that that learning processes are general? Why you study them in a complex situation in which you have exploration, you have reciprocation, you have generosity? Go and look at the old psychological literature on probability matching. And this is what I did, and then we our researchers really extend that research. So our trick was to find the simplest set of situations that we can only, that minimize both reciprocation, generosity, and exploration. Although my earlier research with Al was this big debate, and then there was a big disagreement in the literature. So now it's clearer. Okay, so now I want to present the model, but I will the first model that we propose, the one in this paper, in the 2017 paper, that Tom also mentioned. So we basically propose this really optimistic observation that although the underlying learning processes can be really complex, could be a machine learning algorithm kind of thing, maybe we can approximate their outcome with not too complex model, with model that we can actually write a simple computer program that will derive its prediction and maybe be able to predict some even analytically. To evaluate the potential of this observation, we tried to develop a model that will capture all the results that we ran. Initially, we ran 90 conditions. I presented here about 7 of them. We ran 90 conditions, and then we ran 2 choice prediction competition and challenged other researchers, as As you know, Tom participated in one of the competition. Actually, his team won one of our competition. And basically, we said we run 90 conditions, and we develop a model. We call the model BEAST, for Best Estimate and Sampling Tool. Initially, we thought about this model because we thought the model is really a beast. It's not elegant, and we challenge people. We offer you beast, offer beauty. But later, I'm beginning to think that this beast is more beautiful than. Well, I now have a version of beast that I think is more beautiful. So the model is relatively simple. So what we did, we say here's a 90 experiments that we run. Here is a model. Try to come up with a better model. And we're going to run, in the first competition, we run another 60 conditions. You have to submit, to send us your model by email. And then we run the new condition, the new experiments. And we will compare all the models that were submitted to see which one predicts better. So really interested in predicting. We are not interested in people are rational or not rational. We want a model that can predict behavior in these settings. And the winner of both competitions were some variant of BEAST. That is, they use BEAST. As I said, in the first competition, machine learning tools did not do well. In the second competition, Tom's team proposed a model. They actually had two versions of it. One of it, the one that I actually submitted, was a machine learning algorithm that used BEAST as one of the features, but it gave BEAST a lot of respect. It was a main feature, but they improve a little bit on it. Later they published a paper in which they use BEAST to generate cognitive prior and then estimate a machine learning, more elegant machine learning tool. So basically, this choice prediction competition tell us it's a model like BEAST can actually capture the results. So these assumptions do give you some thing. Now, well, BEAST, as I said, is a BEAST. It includes some complex assumptions. Most of the beastie assumptions were introduced to capture the overgeneralization, the initial behavior. So the initial behavior, in order to capture the initial behavior, initially we hoped that the initial behavior can be captured with model like prospect theory, but prospect theory had a problem in capturing our results because prospect theory, we were not able to find a version of prospect theory that will capture overweighting of rare event and also the risk aversion in our St. Petersburg program. So prospect theory itself could not fit all our results, but we take some idea from prospect theory by assuming that what prospect theory capture is some overgeneralization, and we found a version of BEAST that assumes three types of overgeneralization: some pessimism, some equal weighting, and some sensitivity to perf sign. And with this, we can capture the initial behavior before people get feedback. But the really good news there, that after you have this ugly assumption, that is, then the learning after when the people start feedback can be captured with the idea that subject either do that and continue to do that with some probabilities that diminish, or rely on small sample of past experience. So you only need two parameters to capture the effect of the experience for each participant: the number of past experience you're going to use, and the speed in which his overgeneralization is diminished. And this capture all the results that we got. So here are the open questions, and I ran faster than I planned, but maybe I can continue after so I thought that this will be the end of the first talk, but I will continue. But we'll have time for questions. Then we continue, and if I will not be able to entertain you for the full 3 hours, we will finish early. But now we'll go all the way for lunch. So here are some open questions. Well, so basically what I try to convince you that the impact of experience can be captured with really simple models that assume that with experience people behave as if they rely on small sample, and this trigger underweighting of rare event. But if you really believe that, why people buy lotteries? You know, we get experience with lotteries. People who buy lotteries they know what they earn. Some people buy lotteries every week. By the way, who here bought lottery last week? 2 weeks ago. So people don't buy lotteries so often. But some people do buy lotteries, right? Or those who buy lottery don't raise their hand. But I didn't buy lotteries in the last 40 years. So not everybody buys. So I believe you that most of you don't buy lotteries. But sometimes some people do buy lotteries. So how can we capture that with this model? Another phenomena is if you believe me that experience eliminates loss aversion, what explains the fact that many households are underinvested in the stock market, despite the fact that in the last 100 years the stock market was much more led to much higher profit than safer bonds. So there is some result that could be captured with loss aversion. Another open question is, why is it that subject behaves if they rely on small samples? So I provided some hand waving that people rely on the most similar past experience, that this approximates the optimal strategy. But why and which past experience are most likely to use? Maybe it's just a recency effect. Maybe what we get here is not my complex story of classification-based processes, but maybe subjects just have small memories and they rely on small samples just because they rely on the last 3 outcomes or last 5 outcomes. This is, by the way, what we thought when we started this research. And the more important question is how general are these results? You know, another really funny things about economics and also psychology of decision making, that the reason why Fonoman and Morgenstern talked about lotteries is not because they were interested about lotteries. They only proposed that in order to quantify the idea of utilities. But we study the way people choose between lotteries. But where in life you get lotteries of that sort? Even when you gamble, most of us don't get a description of the pair of distributions, say, I'm going to get this one. So how general are these results? Maybe we only get it when you ask what's a joint outcome of numerical description of some pair of distribution. And what happens if the description is some verbal term, maybe some nudge, maybe some warning? Would we get the same kind of results? So that is the goal of my next second talk, but I will continue now. So let's talk first on the first 2 puzzles. Yes, Maya.
If this is going to be a natural break now, the first part and second part, I just want to make a general comment, especially to all the young economists around. Picturing people as skeptical is wrong, and your story, I think, unnecessarily relies on saying, well, you know, somebody gives us a description and we don't really believe it. The rule of thumb is you're told something, you do believe it. Babies are born trusting. Skepticism has to be learned. Skepticism is alien to our nature. So yes, we are skeptical in some contexts, and there's been a claim by economists that psychologists have ruined subjects because they lied to them so often that if you participate in a human experiment, a behavioral experiment, some people indeed do approach the task with skepticism, but to say that we walk around the world doubting what we're told is a misportrayal. We walk around the world believing every single thing we're told.
Well, I would like to challenge you. And I never read, so what would I believe? You know, I get a message. I don't really read the message. If you look at my email, you'll see that I keep these messages. I read very small percentage of them. Part of the reason that I don't read is because I don't believe them. I just today got some invitation to submit some paper. I didn't open those. Maybe it was from science, but I didn't read it. It is my feeling that it was not from science. So typically there is messages, submit a paper, and then after you submit, they charge you some money, and I don't, and in the initial email, they don't tell me about the money that they're going to charge me later, so I prefer not to read it. So I don't believe it so much, so I don't even read it. In other situations, I believe it too much, and I say, okay, I approve it, and I sign that I agree to something without reading the section. So I think the basic assumption of behavioral economics that the subject comes to the experiments and they read the instruction, and they believe the instruction is wrong twice. First, they don't read, and if they read, they don't believe. And by the way, the reason why I moved to this experimental paradigm is that when I was a graduate student, I worked with Amnon Rappaport, and we study behavior in game. So we ran some experiment in which we described the game to the subject. And initially, I got some interesting results that I thought was good. And then I asked my girlfriend at the time to run some of the subject, and she got different results. And what I've learned from that is the way I explained the subject, the experiment, I biased their behavior. So the way people, so if the subject would just read the instructions, that would be good. So when I saw this gap between the subject that I ran and the subject that my ex-girlfriend ran, I thought, well, maybe we'll give them some quiz. But then I realized that if I give them some quiz, they will behave according to my model, and a different quiz they will not behave. So I think that what people read and what they understand is much less, there are some things that we believe, and maybe you believe more than me. I tend not to believe. I'm really a rational economist. When someone tells me something, I think, what is their incentives? And if I think their incentive is to help me, I believe it. But if my government tells me things, I'm not sure if I believe what they say. And even when my wife tells me something, she tells me I dress well, I'm not sure that she's correct, this is what she feels. I think, of course, I agree with you that economists are really crazy by accusing psychologists, that people believe everything until the psychologists start lying to them. I think there's much more lies in the world. Maybe some of you saw the really interesting Italian movie that had now version in different languages of the group of friends from high school that are really good, the best friend ever, and they decided one day to put a smartphone on they drink coffee together, they put a smartphone on and they decided that today we play a game, when some phone acts, someone else will read. And lots of unpleasant things happening there. So I think that the feeling that we believe everything is because you're thinking about some kind of information that you receive that is trustworthy. And in my case, even when my wife or my daughter tells me something, I also think what are incentives. So I think rational economic theory is much more useful, and this is happening without awareness, I think. So my view is different than yours. Let's see if we have time for... let me continue. Yes.
Can I just, not as profound as Maya's comment, but how, this is in general, there's an assumption going on throughout the talk that when you make a decision, when your subjects make a decision, they make the one decision. How do you deal with the fact that maybe at a certain point what they're learning isn't that they're, from their experience, is that they're actually learning, oh, I'm doing this again and again and again and again. I'm not doing one decision. I'm thinking of these decisions as a group.
Yeah. No, I think the subject might do that, and I will present later that we get some results that that can be explained with the idea that subject typically in the experiment makes some decision and then move to inertia mode and continue repeated. This will be necessary to capture some of the results I will present. So I actually have more results, and so I'm not trying to kill your time. So let me, go ahead, yes.
Will we talk more about the beast model or no?
I will, okay, let me say something about the beast model and why I don't emphasize it. So the beast model have two parts, this overgeneralization and what happened after. Initially, I hope that this overgeneralization will be general. In fact, in the data that Tom presented is doing quite well. Just a little bit more noise in his data. But then, when you think about it, it doesn't, so I have other data sets in which it doesn't do well. So the initial overgeneralization, I think, is not so interesting because you change something in the experimental setting and it changes. So I personally don't want to waste my energy on capturing overgeneralization. I think it's really slippery. You just change the surroundings, the problem around it, and you get different behavior.
I think I'm not really understanding in general what was the beast model. Like, is it a machine learning model that predicts the choice and then it has different
No.
features?
The
Like,
BIS
should-
model start with something like prospect theory.
Okay.
That say when I get this when I get a description, I react to the description, and
But so what are the variables that go into it, and like what are the I really
yeah, I can say something about that.
Actually, I
the
have
function of
I had this, I wanted to ask the same thing, that if you have some additional time, would be great to see, if you don't want to show the initial part of the model, but at least the later part, yeah, not on the initial.
Okay, the later
part,
part, the later, well, the
more
okay.
precise.
Let me
would be
say
great.
something about it is written in the paper, but I think that this overgeneralization part is less interesting in the sense that it's slippery. In different experiments, you get different behavior. What I think is robust is how people update their initial belief. But let me say something about the initial belief. Basically, what we assume, what the BIST assume, that when you see a problem, that's a description of a new task, that remind you, you either go with expected value, in which you don't overgeneralize, you do the right thing, or you do one of three overgeneralization. One overgeneralization says, oh, this is one of the situations like this thing that asked me, send me $50, send me $1 million. This is a pessimism. This guy's going to trick me. So I'm going to expect the worst possible outcome. And that will lead you to select the safer option. Because say, if one option can lead to a loss, probably it will lead to a loss. So if you do this generalization, then you will go against the risky option. You will go for the safe. Another overgeneralization is you think, well, they said that it could be either 101 or 1. And they say the probability of 101 is only 1 in 100. But maybe they are wrong in the probability estimated. Or maybe it's 101 with a little bit higher probability. Sometimes people err in probability estimate. And this is like a story that when you see a gun in a show, in the beginning of the show, you say, well, then you didn't show this gun for nothing. Maybe it's going to be used in the future. So if you saw the 101, this will lead to the so this kind of overgeneralization lead you to sometimes to overweight the error rate, according to BIST. So sometimes you do this kind of overgeneralization, and sometimes you say, oh, this is one of the situations that it's only important to win, and then you get something similar to loss aversion initially. This is how we capture initial loss aversion. So the idea is that it's not, unlike traditional model like expected utility and prospect theory, we don't assume that you have some subjective function in your head. But what we assume that you have past experience in your head, and you now when you think of it, this reminds you one of these four situations. The true one, in which you would just go with expected value, or one of these biased, this one of three overgeneralization. And this is, we have a simple computer program that does this. Yes?
Can I think of this as different object rules? Like you sample different parts of the car? Or put different weights?
It's not rules, because what it does is how you sample. So if you use a pessimism, you tend to sample more from the worst possible outcome.
So is it, again, very basic, but so what is it? Like, is it a neural network or a value function of like?
It's neither one. It's a
combined of,
computer
like,
program that does sampling from the object. Initially, you do sampling from the objective payoff distribution, but the sampling is maybe biased in one of these three ways. So these are sampling rules. Yes.
So this is how you start the behavior. This is how the
Yeah.
rules based on which the behavior is at
Yeah. And after you start, and this is a part that I think is general, and I will present to you
more formally.
more data how you do that. No, this is very simple. All what you do after you start, then you either go with your initial, you either go with the old experience, which this capture what the old experiment said, or you just recall a subset of the recent experiences. And if you recall, say now we're in trial number 23, and you say trial number 23 is similar to trial 7, 17, and 19, then you select the option that was best in these three trials.
Right, but okay, yeah. So first the probability with which you choose this or that is some parameter you fit, I guess. Now, for the experience selection, how do you select past instances and
You randomly select, so each subject has a parameter, kappa, the size of the sample. I will present that later in a simpler model, but it's each subject in a particular condition has a parameter kappa, and this subject now, his kappa is 3. He's going to randomly select one of the 3 past experience and do best reply to the sample.
no, I thought you said it selects similar past instances.
Yeah,
or
but,
any.
okay. Our theory suggests that the subject selects similar, but we don't know what's happened in his brain, and we approximate by assuming that he's randomly selected this route.
And then based on the sampled instances, what's the rule that maps that to an action?
Then he selects the option that has the highest pair in the sample. Okay, so now I really don't have enough time to the new topics, and yeah. And if there's another question, or we take a break? Yes.
Just following up. I mean, he actually chose some actions, so
Yes.
he knows the reward. But there are other actions that he didn't choose. So he's looking only at his past experience, or he's also asking himself, situation X was similar to the situation I'm facing
Well,
now. What would I have?
Well, so
gotten
this
in
is
that
what
situation?
confuses people. So we don't take our cognitive model too seriously. So we have a theory that assumes that the subject selects what is similar. But we know that all the past experience, because our environment is static, that all the past experiences are equally similar. So we assume that he thinks that he selects similar situation, but we can approximate the effort to select the most similar situation, but assuming that he relies on a sample of size 3. Randomly selected. And this is what our predictions.
Yes, but he's comparing only the actions that he actually took.
No.
No.
He recall, we gave them, as I said, the obtained and the foregone pair. In each trial, he can see what was from selecting A and what was selecting B. And if in the 3 trials that he selected, B provided higher average pair, he will select now B. Okay? By the way, the reason why I stop is not that I don't have enough story to tell you. I have a lot of data to present after the break. But I think, okay, so this was the open question. So let me ask you to think, what do you think the reason is that, I will not present data, but I will just present you the logic so you can think about it if you are bored during coffee break, during lunch break. So we want to understand why people buy lotteries and why they are invested in the stock market. So these phenomena are not eliminated by feedback. So what at first glance, so our story is inconsistent with this finding. And let me try to show you, and I will do it after the break, is how we are trying to address it. We are really going to base on 2 observations here. First, the empirical patterns are not as robust as assumed, for example, by prospect theory. So if you believe prospect theory, and of course Amos and Danny did not think about it as a theory of human behavior, but some people overgeneralize prospect theory to become. Amos and Danny were very careful in saying this is a model of some counterexample for expected utility theory. But if you take the model seriously, as Danny Kahneman always said, don't do, then you would assume that every time you have an opportunity to buy a lottery, you will buy one, because you prefer 5,000 with probability 1 in 1,000 over 5 for sure. But of course, most of us will not do it, as we just realized. Sometimes people buy lottery, but it's not the general pattern. And also, the observation that people are underinvested in the stock market is true, but we also have phenomena that appear to suggest the opposite bias, like overtrading that Professor Aumann mentioned, and also the fact that many of us, especially in Israel, are overinvestment in a small number of assets. Many Israelis, like myself, are invested in real estate, whereas it's a really stupid thing. You know, I teach in class that you should diversify, and I heavily invested in my apartment, And so this behavior appeared to suggest that I like risk in the loss domain. So we get this phenomena. We get a phenomena that people buy lotteries and don't buy enough stocks, but can be explained by prospect theory. But we also get the opposite pattern. So in real life, you get both type of results. You get some results that suggest overweighting of rare event, like buying lotteries, but you also have the opposite result, like checking your email while driving, a behavior that I exhibit quite a lot, and it's really stupid. So the challenge, and also, as I said, with investment, we are some of us are underinvested in the stock market, maybe many people are underinvested in the stock market, but it's not that they always go to the safe as they hold too little asset. Many people hold individual stocks over having an index fund, which is again, the opposite of what loss aversion would predict. So this is one observation. Another observation that I will talk about after the break, that the reliance on small sample hypothesis actually predict the coexistence of this deviation from rational for maximization. And it implies that the deviation, the direction of the deviation is highly sensitive to the exact incentive structure. The same model, reliance on small sample, implies that in some setting you will buy stupid lotteries, but in other situation you will behave it if it won't happen to you. Okay, and similarly the same model suggests that in some situation people will be underinvestment in the stock market, that is, will behave if they are loss averse, but the same reliance on small sample implies that in other situation you will exhibit the opposite bias, and this depends on the correlation between the different risky options. And after the break, I will present experiments that test these predictions. Okay, so let's take now a break.
So before we go to lunch, we are approaching the end, and it's really an opportunity to thank in person the wonderful stuff that we used to do. I think you know I'm not very well from corresponding, but there are a lot of other people that are involved and did very hard work. Iris, the chief administrator,